Hi everyone, welcome to another programming video. So today we are going to talk about Fibonacci function, Fibonacci series using recursion in Python. And this is another request by one of the students. So I created this program. We have this program, and first let me just walk you through each step. Okay, let's first discuss what Fibonacci series actually is. So when we talk about Fibonacci series is actually it is a series of numbers in which every number is the sum of two preceding numbers. So obviously you will always need two numbers at least to start with. So if let's say you have 0, 1, and then you can go on and on. So 0, 1, right? And the next number will be the sum of these two numbers. So the next number will be 1, and the next number will be the sum of the two preceding numbers, and those numbers will be 1 and 1. So 1 plus 1, 2, and then the next number 2 plus 1, 3, next 3 plus 2, 5, and so on, right? So this is the function, this is the program actually, and we are going to use recursion here. Recursive function means the function calls itself in the definition, right? So definition body. So this is the name of the function, Fibonacci function, and then inside the function we are calling this function again, right? So that means it is a recursion, it is a recursive function, and it is helping us, it's going to help us calculate Fibonacci series, right? So we'll go through this function. As you can see, this function calculates the nth Fibonacci number using a list of f. So f is a list, it has two elements, 0 and 1, and as I told you, you will need at least two elements to start with, right? And then the series can go on, and you can decide the you can decide the length of this series, Fibonacci series, right? And this list f, because we need two numbers to start with, so I'm going to put them in the list 0, 1, and this list will also be used to store further calculated values to optimize performance through we are going to use this list, right? So how we are going to go about it? First, this part, so we are defining this recursive function here. First, we are going to check if the requested Fibonacci number is already in the list f. And how is that possible? If the value of n is less than the length of this list, and it is also more than 0, right? So if value of n is 1, length of the list is 2. So if the value of n is 1, that means we just need to return the first value if the requested value is already there. And in the end, we are just going to, because all these steps will be skipped since the first part comes true. So we are going to skip all the steps, and then the final one is printf. So we are just going to print the list, that is 0, 1, right? If the requested Fibonacci number is not in the list, then we need to calculate it recursively, and this is that step, right? So we are going to calculate it recursively. What I mean by that, and then we are also checking if n, value of n, is greater than the length of the list f, so it is more than 2, we will append the newly calculated Fibonacci number to f. So for that we are going to use f dot append x, right? So we are going to keep appending all the values, right? And to find the next Fibonacci number, I'm going to use this variable x, right? So every time I'm returning x, I'm just going to append it in this, right? In the list f, I'm going to append x. To calculate the next number, I'm going to use this statement. Let me show you this one. So this is Fibonacci function n minus 1 plus Fibonacci function n minus 2, and I'll tell you why we are using this. I'm actually going to give you one example to help you understand. So let's see. And again, I know this concept is a bit confusing. So if you don't understand, please feel free to ask in the comments. I'll try to explain again. So again, first we are initializing this list F with first two Fibonacci numbers, 0 and 1. These values will serve as the base case for the Fibonacci sequence because we need two numbers to start with, right? Next, we are defining a recursive function, Fibonacci function. You can name, you can have, any name. I'm giving Fibonacci function because we can easily remember that. And this function is taking this integer n, right? And it is taking this integer n as an argument. So this is the Fibonacci desired Fibonacci number. So if I want 5 values, I can give 5. If I want 3 values, I can give 3, and so on, right? Inside the function, it is first checking if the requested Fibonacci number is already in the list F. If it is greater than 0, if yes, it returns the corresponding value from F, right? If the requested Fibonacci number is not in the list, it calculates it recursively by adding the n-1th and n-2th Fibonacci number, as I explained here, n-2th Fibonacci number. It is going to add these two numbers, and then it is storing these two numbers in variable x, right? And again, if n is greater than the length of the list F, it will append the newly calculated Fibonacci number x to the list, right? And then because this is definition, right, we are just defining this function. So when I run this code, this function, this is just a definition. To actually run this code, we need to call this function, right? And we are calling it after getting some value n from the user, right? And then we are calling this Fibonacci function with n to calculate the nth Fibonacci number, right? And then because the result is stored in F, list F, we are going to print it in the end, right? Okay, and again, because we are appending the values, F will contain all the calculated Fibonacci numbers up to, that particular last Fn, right? Okay, now I'm going to give you two examples, one where we will only run the base case, and another example where we will run the second case, right? So for the first one, I'm going to take the value of n as 1. So let me run this code. Okay, we'll save it and run it, right? So I hope you can see the screen. So they are asking me to enter the value of n, and first, for the first part, I'm going to take n as 1. So I'm going to enter 1, and as you can see, only the first case gets executed, right? So this first case only, so we have only F, right? F gets printed 0, 1. Fine. Now, as I told you, initial values of F are 0 and 1, right? And when this first base case gets executed, right? Because why first case will be executed? Because n's value is n is 1, so it is like it comes under first case, right? Because n is less than length of F and is sort of like greater than 0, right? So we are going to return F n-1, which is F0, that is 0. So after the function call, F remains 0 and 1. So script will print F. Fine. So output for n equals to 1 is this only, 0 and 1, this list. Now I'm gonna run it one more time, and now if I, let's say, provide the value of n as 3, now it's going to print 0, 1, 1, right? Why does that happen? That is because now the first case will not be executed. Now the second case gets executed, right? Because n is greater than length of f, right? And so x will be calculated by calling Fibonacci function n minus 1, that is 3 minus 1, 2. And then the second part is, what was the second part? It's n minus 1. So 3 minus 2, that will be 1, right? And again, this is what? Fibonacci function for 2, right? That means we are going to take the value of n as 2 now, right? So again, this function will be called again with the value of n as 2. Fine. So 2 means, again, we will check with this one. Is it less than equal to length of f? Yes, right? So first case is true again, and then this thing will return 0 and 1. So that's being said. After that, we will call the second part, that is Fibonacci function for 2, for 3 minus 1, 2, 3 minus 2 will be 1. So when the value is 1, and we've already calculated this for n equals to 1 earlier, and it is 0, so it will return 0, right? So we have two values now. The first value is 1 because 1 is returned when we execute it for the first time, and for the second part it returns 0. 1 plus 0 is 1. So 1 will be appended to f, right? So it becomes 0, 1 and 1, right? Similarly, if the value is, this time n was 3, if the value is 4, it will execute for 4 minus 1, 3, and 4 minus 2, 2, and then so on. Like it will keep on repeating the same thing. Fine. So I just took very simple example with 1 and 3 using the given script to just help you understand how it does that, and how it stores previously calculated values to avoid any redundant calculation. I hope this is clear. If it's not, feel free to ask in the comment section, and yeah, I'll see you next time with another program.